What if we could bottle the power of the sun itself and put it in a machine right here on Earth? We're talking about recreating the cosmic furnace that has burned for billions of years, the same blazing heart that gives life to everything. This isn't science fiction anymore, because scientists just shattered a world record by keeping artificial sun plasma burning for over 1,000 seconds straight. Hit that like if you're ready to witness humanity's boldest energy gamble yet, because what you're about to discover will change how you think about power forever. Right now, in laboratories across the planet, teams are racing to crack fusion energy, the holy grail that promises virtually unlimited clean electricity with no carbon footprint. China's East Reactor maintained high confinement plasma for 1,066 seconds in 2025, more than doubling its previous record and proving we're closer than ever to making stars on Earth. This is the moment where fantasy collides with reality, and the stakes couldn't be higher for our energy-starved, future-demanding solutions. But here's the mind-bending part. To make fusion work, we have to heat hydrogen gas hotter than the core of the sun itself. We're talking about temperatures exceeding 100 million degrees Celsius, which is 6 to 7 times hotter than what's happening inside our actual star. At those insane temperatures, matter transforms into plasma, the fourth estate beyond solid, liquid, and gas, a supercharged soup of atomic nuclei and electrons. The challenge isn't just creating those extreme conditions, but holding them steady long enough for atoms to collide and fuse together, releasing massive bursts of energy. Think about it like this. If you tried containing something that hot in any physical container, it would vaporize instantly, turning to dust before your eyes. That's why scientists use invisible magnetic fields shaped like a giant donut to trap the plasma without ever letting it touch the walls. These machines are called tokamaks, and they're engineering marvels where superconducting magnets twist and bend reality itself to cage a miniature sun. The payoff is staggering, because when hydrogen isotopes fuse into helium, they release energy on a scale that makes coal and oil look like candles. One bathtub of seawater and a laptop battery's worth of lithium could theoretically power one person's entire lifetime. And there's no long-lived radioactive waste like fission. The fuel is everywhere, because fusion plants get their hydrogen isotopes from seawater, meaning our oceans hold enough energy for billions of years. But getting there requires solving problems that have stumped physicists for over 70 years. Problems that push the boundaries of science and engineering. The first barrier is reaching ignition, the point where the fusion reaction produces more energy than you put in to start it. In 2022, scientists at Lawrence Livermore National Laboratory achieved the first net positive energy gain from a controlled fusion reaction. A breakthrough moment. That ignition lasted only a fraction of a second, but it proved fusion could actually work as a power source rather than an energy drain. Now the race is on to sustain that reaction for minutes, then hours, then days, which is what you need for a power plant. China just proved it's possible to hold plasma stable for nearly 18 minutes straight, a massive leap that shocked the global fusion community. Meanwhile, in southern France, 33 nations are collaborating on ITER, the largest fusion experiment ever conceived by humanity. ITER is a colossal international tokamak designed to prove fusion can work at the scale needed to feed entire cities with clean energy. The reactor is so massive that individual sector modules weigh over 1,200 tons, heavier than 2 jumbo jets combined. When ITER fires up for its first plasma operations in 2035, it'll be a milestone that reshapes energy history forever. But here's where things get truly wild. Private companies are now betting billions that they can beat the big international projects to market. Over $10 billion in private investment has flooded into fusion startups, with money pouring in from sovereign wealth funds and tech giants. Commonwealth Fusion Systems has raised over $2 billion and is building a demonstration plant called SPARS outside Boston, targeting 2026. They're using high-temperature superconducting magnets that could revolutionize reactor design, making machines more compact and efficient than ever imagined. Another company called Helion signed a landmark deal with Microsoft to deliver at least 50 megawatts of fusion electricity. The first commercial power purchase agreement. Google partnered with Commonwealth Fusion to secure power for energy-hungry data centers, driving artificial intelligence, signaling massive tech industry confidence. The fusion industry now employs over 4,600 people directly, more than 4 times the workforce from just 4 years ago. Type 1 Energy announced plans to build a Stellarator fusion machine in Tennessee, partnering with the Tennessee Valley Authority for deployment. That's a utility committing to buy fusion power once it's ready, a vote of confidence that this technology will actually deliver. But let's talk about what fusion really means for the future, because the implications stretch far beyond just keeping the lights on. Fusion offers firm, 24/7 baseload power without the intermittency issues that plague solar and wind energy on cloudy or windless days. It could reshape how to decarbonize industries like steel production, cement manufacturing, chemicals, shipping, and aviation that need constant, reliable energy. Modeling by MIT suggests that fusion could supply up to 50% of global electricity by 2100 in the most optimistic scenarios. The economic impact is staggering because MIT's analysis shows fusion power could add $68 trillion to global GDP conservatively. In more aggressive scenarios, that number jumps to $175 trillion as fusion becomes the backbone of planetary energy systems. Fusion doesn't just bring clean energy but also cleaner air, better water access, improved human health, and quality of life for billions. Think about it. No fossil fuels means no air pollution choking cities, no oil spills poisoning oceans, no mining disasters destroying landscapes, no long-term radioactive waste means no Chernobyl or Fukushima nightmares, no nuclear proliferation risks, no weapons-grade material to worry about. The fuel is so abundant that we'd never run out because deuterium exists naturally in seawater and tritium can be bred from lithium. You could power the entire planet for millions of years without ever exhausting the supply, making energy scarcity a relic of history. Yet the progress in 2025 alone has shattered those cynical timelines because records are falling faster than anyone predicted. Engineers solved frontier issues in heating stability, controlled precision, and diagnostic accuracy that once seemed insurmountable, showcasing comprehensive scientific expertise. Advanced simulations powered by artificial intelligence are predicting plasma behavior with unprecedented accuracy, guiding experiments in real time. The Department of Energy just released a national fusion roadmap aimed at delivering commercial power to the grid by the mid-2030s. International collaboration is accelerating too, with the IAEA fostering global dialogue and over 160 fusion facilities now operational or planned. Here's the speculative scenario that keeps scientists up at night with excitement. Picture the early 2030s. Virginia, a newly built power plant. An engineer walks into the control room, fingers hovering over a console, heart pounding, knowing history is about to be made. She presses the ignition button and inside the tokamak chamber, hydrogen isotopes begin colliding at unimaginable speeds, fusing into helium. The reaction sustains itself, burning like a captive star, pouring 400 megawatts of clean electricity into the grid within nanoseconds. Homes light up, factories hum to life, data centers spring into action, all powered by the same process that fuels the cosmos. That moment marks the dawn of a new era, the first commercial fusion plant feeding power to regular people living regular lives. Within a decade, more plants come online, each one proving the technology is scalable, reliable, and economically viable at massive scale. Fossil fuel plants start shutting down, coal mines close, oil rigs stand idle, and carbon emissions plummet as fusion takes over. Energy prices stabilize because fuel is virtually free, pulled from seawater in endless supply, breaking the stranglehold of geopolitical energy monopolies. Developing nations leapfrog dirty energy infrastructure, building fusion plants from scratch and electrifying regions that never had reliable power before. Climate change slows as humanity's carbon footprint shrinks, giving ecosystems a chance to recover and future generations a livable planet. The technology spins off into other applications like compact mobile fusion units, powering remote communities, long-range spacecraft, or deep-sea research stations. Medical isotopes produced as byproducts revolutionize cancer treatments, improving diagnostics and therapies that save millions of lives worldwide. Fusion-powered desalination plants turn oceans into fresh water, ending droughts and water scarcity in the most arid, desperate regions of Earth. Humanity's energy problem transforms from a crisis of scarcity into a challenge of managing abundance, a problem we'd gladly take. But we're not there yet, and the road ahead is still paved with engineering challenges, funding gaps, and technical unknowns. Costs are high because building these machines requires precision manufacturing, exotic materials, and massive upfront investments that take decades to pay off. Yet the momentum is undeniable, and the confluence of scientific breakthroughs, Private investment, international collaboration, and political will is unprecedented. We're watching history accelerate, and the timelines that once seemed laughable are now looking achievable, even conservative in hindsight. This isn't just about energy, it's about survival, progress, and the kind of future we want to leave for those who come after us. Fusion represents humanity's ability to dream big, take on impossible challenges, and bend the laws of physics to serve our collective needs. It's the ultimate test of whether we can innovate our way out of existential threats like climate change and resource depletion. The question isn't whether we can create an artificial sun anymore, because we've already done it, even if just for fleeting moments. The real question is how fast we can scale it, perfect it, and deploy it before the planet reaches irreversible tipping points. So here's the takeaway that should make you sit up and pay attention. The future of energy is being written right now in laboratories and boardrooms. Every record broken, every second of sustained plasma, every billion invested, every partnership signed brings us closer to a world powered by stars. This changed how I see the future, because fusion isn't a distant fantasy. It's a present reality clawing its way into existence through sheer willpower. Smash that subscribe button if you want more deep dives into the impossible technologies reshaping our world in real time. Drop your wildest theory in the comments below. Will fusion save us, or is there another energy revolution lurking just around the corner? Share this with anyone who cares about the future, because the artificial sun is rising, and it's going to change everything we thought we knew. The race is on, the stakes are planetary, and humanity is betting its future on bottling starfire right here on Earth. What answers will we uncover next? And who will you tell about this revolution, because the story of energy is being rewritten before our eyes?